Hello students, welcome to Talk on Civil Engineering. Let us see one more problem, that how we can calculate the extreme fiber stresses in prestressed concrete structures. So here we have a question is asking to find out the extreme fiber stresses in the concrete at midspan of the section. And for that he has given the prestressing force, and the section of the prestressed concrete beam section is given, span also given, and the UDL, which is including the self weight, he has given. Right, now let us calculate the stresses at the extreme fibers. So for that, we need to know what is the eccentricity of the tendon. So here not mentioned what is the eccentricity of the tendon. So firstly, let us find out what is the eccentricity of the tendon. So here we have a rectangular beam, okay, and so which is having 600 mm depth and 400 mm width, okay, and he said that the tendon is located at the lower third point. So lower third point in the sense, lower third point means that is h by 3 of the section. So from the bottom, so it is from bottom. Okay, so from bottom, the tendon is located at h by 3. So that means h is 600 divided by 3. So it will be 200, right? So it is 200. So from bottom, so the tendon is located at 200. So the tendon is located here. Okay. And the center we know it is 300. It is 300. So if you subtract 200 from 300, so the eccentricity of tendon will be 100. Okay. So now we got the eccentricity of the tendon, E is equal to 100 mm. Okay. Now let us calculate the stresses. So the first one, we need to calculate the direct stress. Direct stress due to the prestressing force, right? Due to prestressing force. Okay. So formula we know, plus P by area of concrete. Force into A, force divided by area. Okay. So P, prestressing force, he has given in the question, it is 960 kilonewton, so 10 to the power of 3. And area of concrete, so area of concrete, it is 400 into 600. So 6 4 24, it is 240 into 10 to the power of 3 mm square. Okay. So 240 into 10 to the power of 3. So it will be plus 4 Newton per mm square. Okay. Now we got the direct stress. Now let us calculate the stress due to the eccentricity of tendon. Stress due to eccentricity of tendon. Okay. So we know the formula, it is minus or plus, because the stress above the neutral axis, it will be minus, below the neutral axis, it will be plus. PE, that is moment divided by the section modulus Z. Okay. Minus or plus, P is 960 into 10 to the power of 3, and eccentricity, it is 100 divided by section modulus. So section modulus, we know Z formula, it is BD square by 6, right? So if you substitute B value, it is 400 into 600 square divided by 6. So the section modulus will be around 240 into 10 to the power of 5 mm cube. Okay. So 240 into 10 to the power of 5. So the value will be minus or plus 4 Newton per mm square. Okay. Now let us calculate the stress due to the external load. Stress due to the UDL. So this UDL is including the self weight. That means you don't need to calculate the self weight again. Okay. So we know the formula, it is plus or minus, plus above the neutral axis minus below the neutral axis, right? Moment due to load divided by Z. So for that we need to calculate what is the moment, the UDL load into WL square by 8. So W, how much? It is 16. L is 6 divided by 8. So it will be 72 kilonewton meter. Okay. Let us substitute. M is 72 into 10 to the power of 6 in Newton mm, divided by section modulus is 240 into 10 to the power of 5. So it will be plus or minus 3 Newton per mm square. Okay, so with this we have calculated the extreme fiber stresses. Now let us draw the stress distribution diagram. Even though here in this question, in the question, he is not asked to calculate what is the stress distribution diagram, but if you draw the stress distribution diagram, it will be easy to calculate what is the total stress at top and at the bottom. Okay, so let us draw the stress distribution diagram. So here we are having tendon. This is the center. Okay. So now we'll have the direct stress, which is positive throughout the section. That is 4 Newton per mm square plus 4 Newton per mm square on bottom, plus due to the eccentricity negative on top. So how much? 4 minus 4 Newton per mm square, and at bottom it is plus 4 Newton per mm square, plus due to the external load on top it is positive, plus 3 Newton per mm square, and at bottom it is negative, sorry, minus 3 Newton per mm square. Now the resultant on top, 4 minus 4, it is 0, plus 3. So it is 3 plus 3 Newton per mm square on top, and at bottom 4 plus 4, it is 8, and again from 8 you need to subtract minus 3, so it will be 5 plus 5 Newton per mm square. So this is how we are going to calculate the stresses. The extreme fiber stresses at top is 3 Newton per mm square, at bottom it is 5 Newton per mm square. Okay, so thank you all.